When I do surface mount soldering, I like to start with the most complicated part, the one with the highest leg count and the one that's most centrally located on the board. That way if I screw up, it's easier to fix it before you have all the other components around it. In this board, it's actually kind of nice that there's really not a lot of components around the two surface mount chips, where most boards there'd be bypass capacitors or any other things right close up to the chip, so it'd be really hard to go back in and add the chip after you've installed the bypass capacitors. So first thing we're going to do is tack two opposite legs on this chip to hold it down, and this little dot is orienting which one pin 1 is. Same with this dot here, and I don't know if you can see it in the lens, but here's a little dot right there on this chip, and that's pin 1. We're not actually going to start with pin 1. We're going to start with, I think on this one, what is it, pin 14 and pin 7, the ones we're going to use to tack this thing down with. So if I'm not too smooth, forgive me. It's been probably about a year since I've done any surface mount soldering. And we're actually using the 0.8 millimeter solder that came with this solder station, so we might need to go to something smaller. I guess that flowed okay. So I put a little down to start with, and I'm gonna just kind of put the chip where I think center is, where it's centered on the pad, I should say. Yeah, we're going to need more heat. So I'm at 600. I'm going to crank it up to 660 and see what this is like at 660. I'll put a little solder on the tip so I have something to get the heat going with. Put it right where I think it should go. Yeah, that worked a lot better and quicker. You see I'm a little more this way than that way. It's really not going to matter too much on this kind of chip, and that's why those pads are so wide, is to make it easier for you to actually solder it. So now that I have that one tacked, I'm going to flip it this way. I'm going to tack this opposite corner leg right here. What I'm trying to do is heat both the leg and the pad at the same time while getting just the tiniest amount of solder in there to help heat transfer and get it to flow. So that's actually pretty good. Now we're going to work on putting the legs down. And the reason I'm doing these two opposite legs like this and not pin 1 is I'm going to come this way and do the soldering. So I'm going to solder this one, this one, this one, and while I'm holding the iron like this, I'll tend to heat these back legs up, and if I went this way, these would already have solder on them, and you can run a risk of solder bridging. If these are already hot and I'm applying solder, the ball might jump backwards because these have already been preheated, and try and get a solder bridge going between two legs. So we'll see how this goes. This is the other gauge solder I have, by the way. I'll just show you in the viewfinder so you can see the difference. This one I think is 0.4 millimeters. This one's 0.8. So you can see if you were soldering, it might behoove you to get a smaller diameter wire or solder. It would be easier to control the proportions, much easier to control your proportions. Alright, so I'm going to kind of reflow this one a little bit. See that little booger hanging off of there? There we go. Now I'm trying to touch the pad and the leg with that little bit of solder on the tip to heat those two up, and then I'm going to just bump it with a little solder. Yeah, that's not going to work. I'm going to have to probably go with the smaller solder. Let's see how far we can get. Alright, I can't really even see if it's getting in there. Let's try this solder real quick and see if we have better luck. Yeah, this one seems to flow a little bit better. I'll flip it over here and go this way. That one's already been done. Now there's really nothing wrong with getting too much solder down other than you run the risk of causing solder bridges. So if you get a little bit more solder than you think you should have, don't struggle too hard to get out of your way if it's not going to hurt anything. Just go ahead and leave it there. And clean that one up a little, clean that one up a little. So this solder station, or the solder that came with the solder station, I don't know if it's has a flux core to it or not. I really can't tell, and it really doesn't say. So that might be the problem we're running into, is there's no flux in it. I know this is rosin core. Let's see. No, it's flux core. So this solder here, this finer diameter. So that's why it seems to work a little better. Plus it's a finer diameter. All right, let's do the next surface mount chip. Like I said, I'm not going to do pin 1 because I want to come this way, and then I want to come this way on this side. So I'm going to do start with pin 4, which is this one. And then pin 8, which is that one. I shouldn't have flowed pin 8 yet, but that's okay. So I'm just kind of holding it there. I'm not forcing anything. I'm going to heat the solder and just let it fall into place once I see it starting to flow. All right, let me get a little bit more solder on the tip of this thing. Solder is the key to heat transfer. It increases the surface area of your tip. It allows the heat to flow from the tip into the pin and the pad. All right, so there's that one. I'm gonna come over here and just kind of touch it there. There's that one. Kind of hard for me to see with this weird angle I have. I've preferenced the angle so the camera can see it much better than I can see. You can see that's got a little bit too much solder. There we go. All right, so that's our 2 big chips, or our 2 chips done. The next thing I want to do is anything that looks like it has a little too much solder or little pokies, I'm just going to kind of heat it up with the soldering iron and see if I can get the surface tension of the solder just to pull it off with the iron. I'm going to actually bump the temperature up to, excuse me, 700 degrees, because 690 is just still a little too low. All right, So we're going to put R18 in there, which is a 1K resistor. We can tell it's a 1K resistor because it's 102, which is 10 with 2 zeros, which is 1,000 or 1K. So we're going to look through our parts here, and actually the easy way to find is count how many 1K resistors we have. In the schematic we have 7, and they've given us 7 in this tape reel as opposed to like this tape reel that has 4, so I know these are all the 1Ks. So next thing I'll do is go through and put all the 1K resistors in, which will save me some time of having to hunt back and forth for parts. So I like to just peel the plastic back one at a time. This is kind of the hard part. You got to flip it out and get it to land right side up, which that's upside down. There we go, that's right side up. So we're going to put a little bit of solder on this pad. I'm going to turn it this way. We're going to grab this resistor, and I'm going to just heat the solder up, and I'm going to carefully move the resistor into it. There we go. I can actually pull it my way a little bit. If we had a heat gun, we could actually heat this up when we were done, and the surface tension of the solder would correct all the weird orientations of the part. They would actually float on the solder and self-center themselves. Alright, so the next 1K part we're going to look for, that was R18. Let's see what else is close here. R8, which is here. R7. R6. Okay, so we'll do R8. If you look on the soldering tip, you see how the solder is only attracted to this one spot right here? It needs cleaning. Oops. Stuff is just so small. Alright. That one looks a lot better. Get better alignment on it. Let's try this. I'll just set the solder there and bump it. That one actually looks pretty good. R6, which is next to it, is also a 1K. So we'll get that pad ready. You see, I'm just putting just the smallest amount of solder on there. Really, it's very minimal amount of solder that's required. I'm going to heat this up. Slide the resistor into it. Alright. Flip it this way so I can get a good angle on it. There we go. Alright, so what's the next part? R1, R4, R5. There's an R1, there's an R4, so we can go ahead and do those. Let's do both of these at the same time. All right. You see how quickly those resistors heat up and take the solder. They don't need that much heat. When you get a big ball on the end of your soldering iron or solder, sometimes it's worth it just to tear it off, because what'll wind up happening is you put too much solder down, then you're going to be struggling to get the excess solder off. See, this resistor is actually too far this way, but I think it'll be fine. All right, what's next? That's 1, 4, 5. Where's 5 at? There's R5 right there. Go ahead and get that. No, that one's kind of crooked. Ah. Sometime in the quest for perfection, you wind up hurting more than helping. And the perfect amount of solder really on any surface mount part is just enough solder to start to wick up the part and have a little bit of a curve. If it's not coming up to the tip, like on these feet, you want it to just barely touch the top of the feet, and any more than that's too much. All right, so the last part we have, that's R5. R1 is the R1 we did. R4, R5, R7. R7 is the next one we're looking for. That's the last 1K. I'm reading this upside down, so let's see. R9, there's R7. And this is one of the reasons we're doing all the surface mount first, is if I did the through mount components and put these resistors in, there's no way, or these capacitors in, there's no way I could ever get my tip in there. All right, that's pretty good. So the next component we have is a 200 ohm resistor. All right, so let's find R9 is one. We can do R9. Let's see, is R15 one? No. All right. So we'll just do the R9 first. All right, what's the next one? R12. So So there's an R12. What about R13? Where's that one at? R13. And R14 right there. So as a resistor code, it's 200 ohms is 201. It's always the first two digits and then the number of zeros. Now we're just going to do the first side of multiples of these. And try and get going a little faster here. Sometimes if you try and do this a little too much, you wind up forgetting to solder one side of a resistor or one of the legs. So don't try and be in a rush to be too efficient. All right. So the next we have 10K resistors. There's 3 of those. There's the 10K resistor pack. I'll just open these up. Yeah, the smaller the package, the harder it is to open. These are actually pretty big resistors. These are 0805s. So there's 0603 and 0402, which are 2 different sizes smaller than these. All right, so R2, R3, and R19. R2, R3, and R19. That's really nice. They're all together right there. Oops, I tombstone that one. Like I said, this is the first surface mount soldering I've done in probably in over a year. With moving and changing jobs and whatnot, I just really haven't done much. I'm sure if I did this every day, I can make this look amazing, but I don't. Alright, so now we need R10, which is a 1.5K. Yep, here we go. This one says 152. We'll go ahead and flip this over. we got R16 right here, and R15 right here. That's a lot of solder there. Sometimes a good trick you can do to get solder off is clean your soldering iron and use the surface tension of your soldering iron to suck off the excess solder. So we want to do I can barely read that. Yeah, this one's a 47K. The worst thing is if you get in a rush and flick this thing and shoot the resistor across the room and have it land in the carpet, you'll never find it. Not that they cost anything, but if you don't have one, it'll be a disaster. Don't you wish you had a machine that can print these little resistors? This is truly printing money. Get this last one open. This is a 30K. Alright, that looks pretty good. Now it looks like we just have through-hole components left. So we're going to go ahead and do like I said, is we're going to work from the center and work our way out. So center C4. Let's see what C4 is on here. It's a ceramic capacitor, 0.1. There should be two of them. Okay. So here's one of them. So you got to be, when you deal with ceramic capacitors or electrolytic capacitors, you got to be real careful at how far you allow the leads to flex. You can actually break the leads off up inside the capacitor, or pull them out and actually cause problems. Alright, so there's C4, and where's the other capacitor? C1 is the other capacitor of this size. So that one doesn't really want to sit in there, so what I'm going to do is just pull the leads back a little bit from each other. Just pull them a little tiny bit. Oop. So they want to stay in place. I should go and probably change the tip, but I'm just going to leave this tip I use for surface mount and go ahead and use the bigger solder that the solder station came with. And I like to cut not only the lead off, but a little ways into the solder. when I cut component leads. Alright, so let's see what else. As well as working from the inside out, I also like to work from the lowest point to the highest point. Reason being is I like to flip the board upside down and actually use the component to help hold itself in place while I solder it. So if you do the tall parts like that variable resistor, there'd be no way to flip those over and have those capacitors stay held in place by pushing into the mat. So the next thing we have here is C7, which is 20 picofarad. We'll go ahead and toss that in there. Pull the legs back a little bit so it stays in. Cut those off flush. Alright. So these two little diodes here, D2 and D1, they're both 1N 4148s. When you put the diodes in, you got to be careful about the orientation of where the stripe is, or the cathode. So we're just going to give these each a little bend like that. See the stripe on this one and the stripe on the overlay here. That goes like that. This one goes here. I'll hold my finger on them, pull the leads just so they kind of stay in place. Alright. What's next that's small? I guess the next small parts are these little electrolytic capacitors. Now on these, you got to be careful when you put these in. There's an orientation to them as well. So most capacitors are marked for negative, which leg is negative. And on most negative legs, the leg is short. But on here, they have negative, but they have positive marked, not negative. Let's see what we're going to do here. It's a 47 microfarad. Oh, right there is 47 microfarad. Put that in. See, it won't slide all the way in without deforming the legs, so we'll just let it go to where it starts to get hard to slide. Gently bend the legs back, and on electrolytic capacitors, never pull on the legs because they're loosely bound inside and you can damage them. So then we got 10 microfarad would be the next one. That is not a 10. What is this one? That is not a 10. There it is. There's a 10. So positive on top, negative on the bottom. And just kind of push it in to the same depth as the last one. 1 microfarad there. Oops. And we'll go ahead and put the 100 microfarad in and get him at the same time. Alright, so the next tallest component would be the LEDs. On this chart, D3 is the infrared light emitting diode, which is going to be the clear one, and D4 is going to be the infrared receiving diode, which is going to be the dark one. Okay, on diodes, they're marked multiple ways. There's a longer leg, which is usually the positive, or the anode, and there's a flat on the bottom. Let me see which one of these is actually, yeah, this red LED, you can actually see the flat on one side, which is the cathode of the diode. And they have it marked both ways on here. It's not always the case though. So they have positive, and they have the flat. So now I forgot which one was which. So we're going to do D3 first. D3 was the light emitting diode. So that's the clear one. I'm going to drop him in. We're going to be real careful pulling those leads back. We don't want to break them. Okay. Then the infrared receiver. In the description, I'll leave a link to where I bought this little soldering kit. It was on Amazon. I think it was like $7 when I initially bought it, and I think now they're up to $10. It'd be something good to practice with before you actually attack something with a soldering iron that you really cared about or paid a lot of money for and ruined it. Especially if you get a new soldering station or something and you don't know what the temperatures are like, or you're not used to the handle or something like that. Alright, so now we're going to put the colored LEDs in. They're marked the same way. We'll do red, yellow, and our green. I'm just going to do one leg of each of these. And then flip it over to make sure they're aligned the way I want. And they are. And now I'll finish and do the other leg. next component, maybe this connector. Let's make sure we're putting this in the right way. It says positive is there. So yeah, if I line this up with that connector, positive will wind up there. Okay. So for stuff like this, sometimes it's a little harder to do if you can't bend the leg. It's easier just to hold your finger on the board and force it down. Then tack it with one leg. Then make sure you're lined up. And then do the other leg. Alright, we're almost done. We've got these two potentiometers left. So the 500K and the 50K. Let's see. Alright, so here's the 500K. You can see it's 550 with 4 zeros. And then there's the screw boss, the adjuster, and there's the screw boss. So it goes in just like that. This is going to be one of those parts I really don't want to bend the legs on. So I'm just going to solder the center lead. Straighten it out, get it the way I like it. Kind of push on it with my thumb to get it sit flat. There we go. Alright, before I finish that one, I'll just get this other one installed. Here's a 50K, which is this one, 50 or 503. There we go. Looks pretty good. I like where the leads are, or the package is sitting, so I'll finish soldering the legs now. Alright. So now I think we're done. It's time to test. Let me go get a power supply.